treatment of Parkinson's disease involves some very clever chemistry. The condition was first described by physician James Parkinson in Britain in 1817 in his essay on the Shaking Palsy. Now it is known to be caused by the death of nerve cells in the brain that produce the neurotransmitter dopamine. Normally, the brain makes dopamine from the amino acid tyrosine. This is found in many foods, like cheese, poultry, bananas, milk, and peanuts. Tyrosine is converted to levodopa, that is then converted to dopamine. Although dopamine can easily be made in the lab, dopamine pills cannot be used to treat the disease because dopamine cannot cross the blood-brain barrier. That's the protective network of closely packed cells that line blood vessels that feed the brain. Levodopa, however, can cross the barrier, and in the brain it is converted to dopamine that then can reduce the uncontrolled movements such as shaking that characterize Parkinson's disease. How come this works? Because not all dopamine-producing cells in Parkinson's disease are dead, so the remaining ones will crank up their production of dopamine when given levodopa. Levodopa is usually given together with carbidopa, known as Levodopa, a drug that inhibits the conversion of levodopa to dopamine by inhibiting an enzyme. That enzyme is aromatic L-amino acid decarboxylase, and this is needed for the conversion. However, carbidopa itself cannot cross the blood-brain barrier, so there's no concern about it interfering with the levodopa to dopamine conversion in the brain. But reducing the chance of conversion to levodopa to dopamine in the bloodstream means that ultimately a greater proportion of the levodopa provided as a pill reaches the brain. Levodopa is not a cure for Parkinson's, but it reduces the symptoms for a while. Unfortunately, eventually, so many of the dopamine-producing nerve cells die that boosting the workings of the surviving ones is not enough to make an impact on the symptoms. That for today is our Cup of Joe.